Hello and Namaskar. One more case in regression or linear regression classical approach, and the case is the lines of regression for two variables x and y are x minus y plus 5 equals to 0 and 100x minus 64y minus 40 equals to 0. Obtain the lines of regression for the two variables v equals to x minus 4 by 2 and w equals to y plus 5 by 4 if standard deviation of y is 5. In this case, the information about x and y available is only two lines of regression or other equations of the lines of regression and value of sy equals to 5. And v is the result of change in origin and scale in case of x, and similarly w is the result of change of origin and scale of y. Now, to find out the lines of regression of v and w, we should have v bar, w bar, bvw, bwv. All these four things. How to find them? First of all, we have to find out all these for x and y. The two regression coefficients, the coefficient of correlation, standard deviation of x, and two means. And then taking the effect of change in origin and scale into consideration, we have to find, or we can find all these for v and w, and then only we can find the lines of regression of v and w. So first of all, on the basis of these two equations, we can find out five things: byx, bxy, rho or r, x bar and y bar. Let's find them. Let x minus y plus 5 equals to 0 be the line of regression of y on x. X minus y plus 5 equals to 0. If it is the line of regression of y on x, y should be the subject of formula or subject of equation. Therefore, minus y equals to minus x minus 5. Therefore, y equals to x plus 5 or y equals to 5 plus x, whatever the case may be. Let's compare it with the standard equation a plus bx. Now, nothing as cofactor of x, so it is 1. Therefore, value of b is 1, and in this equation b stands for byx. So byx is 1. Now, another equation automatically becomes the line of regression of x on y. Let 100x minus 64y minus 40 equals to 0 be the line of regression of x on y. 100x minus 64y minus 40 equals to 0. In this case, x should be the subject of formula. So 100x equals to 64y plus 40. So x equals to 64y plus 40 upon 100. Further simplification, x equals to 64y upon 100 plus 40 upon 100. Therefore, x equals to 0.64y plus 0.4. Therefore, x equals to 0.4 plus 0.64y. Let's compare it with the standard form. X cap equals to c plus by. That means b is 0.64, and in the line of regression of x on y, b stands for bxy. Therefore, bxy equals to 0.64. Okay, on the basis of this, we can now easily find the coefficient of correlation. So, the squared value of coefficient of correlation is 0.64. So, coefficient of correlation is square root of 0.64. It is 0.8. Positive or negative can be. But it must be positive because the coefficients of regression are positive. So, it is 0.8. Now, it is turn of finding the two means from these two equations. Normally, we use elimination technique, but we can use any technique. Now, this time another simple technique is also in my mind. See, this is the equation of x, 0.64y plus 0.4. And the line of regression of y on x is very easy to express. If we substitute this entire value in the place of y, we can have the value of x, and that is x bar. Because if we solve the two lines of regression, the value of x is mean of x and the value of y is mean of y. Because the two lines intersect each other at the mean values of the two variables. So let's try it this time. X equals to 0.64y plus 0.4, and now we know that value of y is something else. Therefore x equals to 0.64 into x plus 5 or 5 plus x plus 0.4. Therefore x equals to 0.64x plus 3.2 plus 0.4. Therefore x minus 0.64x equals to 3.6. Therefore 0.36x equals to 3.6. Therefore x equals to 3.6 upon 0.36. Therefore x equals to 10. That means x bar equals to 10. Because this is value of x at the coordinate of the point of intersection of two regression lines. Now if we substitute x bar in this equation, the result will be y bar. Y equals to x plus 5, therefore y bar equals to x bar plus 5. This is possible in case of line of regression. That is 10 plus 5. So y bar comes to 15. Still two things are missing. Sx and Sy, but Sy is available. Let's find out Sx. Bxy equals to coefficient of correlation into Sx upon Sy. Bxy we found was 0.64 equals to 0.8 into Sx upon 5. Therefore 0.64 into 5 upon 0.8 equals to Sx. If we simplify this with the help of calculator, Sx comes to 4. Now we need to change the origin and rather use the property of change of origin and scale, and accordingly we can find out the coefficients of regression, means and standard deviations of V and W. Let's start. Okay. First of all, let's take means. X bar equals to 10, Y bar equals to 15. Mean is not independent of change of origin and scale. So we have to use whole of these formulae to calculate means, because we cannot ignore change of origin or scale at the time of finding the means of the two new variables. Since V is x minus 4 by 2, V bar will be x bar minus 4 by 2, that is 10 minus 4 by 2, that is 6 by 2. Therefore V bar comes to 6. 3, not 6. Very sorry. V bar comes to 3. Similarly, W equals to y plus 5 upon 4. So W bar equals to y bar plus 5 upon 4. Y bar is 15. 15 plus 5 upon 4, 20 by 4. Therefore W bar equals to 5. So we have now means of V as well as W. Now it is turn of standard deviations. Sx we found 4, Sy is available 5. Standard deviation is independent of change of origin but not of scale. So we we should ignore subtraction or addition at the time of finding the standard deviation of V and W, but we cannot ignore the multiplication or division. V equals to x minus 4 upon 2, but SV will be Sx upon 2, that is 4 by 2, therefore SV comes to 2. Similarly, W equals to y plus 5 upon 2, but SW will be Sy upon 2. We have to ignore the change of origin because standard deviation is independent of change of origin. Therefore, SW will be 5 by 2. No, it is not 2, but it is 4. In this formula, it is 4. I wrongly wrote 2. It is 4. So, SW comes to 1.25. Now we have two standard deviations. 2 means, how can we find out the two coefficients of regression of V and W? We should have coefficient of correlation. What about coefficient of correlation? Coefficient of correlation is independent of change of scale. Change of origin and scale. Therefore, coefficient of correlation between x and y equals to, or rather V and W equals to coefficient of correlation between x and y. Therefore, it is unchanged 0.8. Now we have two standard deviations as well as coefficient of correlation. That means we can find out the coefficients of regression for V and W. BVW will be coefficient of correlation into SV upon SW. That will be 0.8 into SV2 upon SW 1.25. Therefore, BVW will be, simplify this, 1.6 divided by 1.25. So it comes to 1.28. Let me confirm it because this is critical calculation. 0.8 multiplied by 2 divided by 1.25. So it comes to 1.28. Yes. The value written with me was correct, but I was not taking it as it is written against me. Now it is turn of BWV. This is coefficient of correlation into SW upon SV. Coefficient of correlation is 0.8 into 1.25 divided by 2. What is it? .8 into 1.25 divided by 2, that comes to 0.5. BVW comes to 0.5. BWV, sorry. Now we have two means and two coefficients of regression. So we can find out lines of regression. Now this is turn of line of regression. And first it will be of V on W. The standard form will be V cap equals to A plus BW, where B stands for BVW, and formula of A will be V bar minus BVW into W bar. V bar is 3 minus BVW is 1.28 into W bar is 5. So it is 3 minus 1.28 into 5, that comes to 6.4. Therefore, A equals to minus 3.4. So the line of regression of V on W comes to V cap equals to minus 3.4 plus 1.28, because this is positive, W. Now similarly, the line of regression of W on V, the standard form will be W cap equals to C plus BV, where B stands for BWV. But first we have to find out C. The formula of C will be W bar minus BWV upon, into V bar. W bar is 5 minus BWV is 0.5 into V bar is 3. So 5 minus 1.5, so C comes to 3.5. Hence the equation of line of regression of W comes to W cap equals to 3.5 plus 0.5 V. So ultimately these are the final lines of regression of V on W and of W on V. The original question, in the original question the data was available for X and Y, from which we found these coefficients of regression, coefficient of correlation, means of X and Y, standard deviation of X when Sy was 5, and then only after taking into consideration the property relevant to the independence of change of origin and scale, we found everything, mean, standard deviations, coefficient of correlation, coefficients of regression for the new variables V and W, where V and W are respectively the results of change of origin and scale in X and Y. This was somewhat new kind of problem, and I think in online study material, perhaps this is first ever discussion of this kind of problem, and we consecutively discussed two these kinds of problem. The previous lecture was also on some kind of similar problem. I request all of you to go through these lectures if required more than once and understand this, because at university level examinations these kinds of problems have been asked. That's it. Thank you.